Okay, so these problems are trig equations that are a little more complicated than the ones you've been doing because they involve quadratic equations that have to be factored. And so in order for them to be factored, they have to involve the same trig functions on both sides, and you're going to use your trig identities to make that happen. So this first example here, we have an equation that involves tangent squared and secant. And so if we go back and look at our trig identity that I wanted you to memorize, sine squared theta plus cosine squared theta equals 1. So we know that we can get an equation involving tangent squared theta if we divide that whole equation through by cosine squared theta. And if we do that, we will get tangent squared theta plus 1 equals secant squared theta, which means that tangent squared theta is equal to secant squared theta minus 1. Okay, so we're going to use that tangent squared theta, and we're going to plug that in for tangent squared. So 3 times tangent squared theta, which is secant squared theta minus 1, so secant squared theta minus 1 equals 7 secant theta minus 5. And now we're going to distribute the 3, so we'll have 3 secant squared theta minus 3 equals 7 secant theta minus 5. And now we have a quadratic equation, so we're going to get everything on one side and set it all equal to 0. So 3 secant squared theta minus 7 secant theta plus 2 equals 0. All right, now we have a quadratic equation, and it's just like any other quadratic. We can factor it if it's factorable, which it is. So by putting 2 little pairs of parentheses here, we're going to factor it into 2 binomials. Factoring it is just like factoring 3x squared minus 7x plus 2, except x is secant. So you're going to have 3 secant theta here. You're going to have secant theta here. And you want 2 numbers whose product is 2, which means 2 and 1. And you'll also get a middle term of negative 7 secant theta. So to do that, you would have to put the 2 here, so you would get 6 there, and then you'd have to put the 1 here, and that'll give you another secant. So if you make them both minus, then you're going to have, for your middle term, you're going to have negative 6 secant theta and minus 1 secant theta, which would give you that negative 7 secant theta. So it all works. And now you have 2 binomials multiplied together to give you 0, which means one of them has to be 0. So either, well, both can happen. Secant theta minus 1 is 0. Secant theta minus 2 is 0. And you just need to solve these 2 equations. So 3 secant theta is equal to 1. And that means that secant theta would have to be 1/3, which means that cosine theta is the reciprocal of that, which is 3. Well, we know that cosine theta is never 3. If you think about the graph of cosine, it goes up to 1, down to negative 1, back up to 1, back down to negative 1. If you think about your unit circle, as you go around the unit circle, the values stay between negative 1 and 1. So there is no such angle that has a cosine of 3. So that's just not even a possibility. All right, and then we have secant theta equals 2. Well, secant is the reciprocal of cosine, as I just was saying. And so this means that cosine theta would be 1/2. And since we want to know all angles between 0 and 360 that have a cosine of 1/2, that's going to be your 60-degree angle and 300. So those would be the solutions for that equation. All right, if we look at the equation up here, we have 2 sine squared x equals 3 plus 3 cosine x. And to do this problem, we're going to use sine squared theta plus cosine squared theta equals 1. Again, we're going to use this equation right here. So this time we're going to solve it for sine squared. Sine squared theta equals 1 minus cosine squared theta. And we're going to do that so that we will have all cosines instead of a sine and a cosine, because we want this to be a quadratic equation that we can factor. And we can't do it when there are 2 different trig functions in there. So we're going to substitute 1 minus cosine squared for the sine squared. So 2 times 1 minus cosine squared x equals 3 plus 3 cosine x. So now we have an equation we can deal with. It's just going to be a quadratic equation in cosine x. So we'll distribute the 2. 2 minus 2 cosine squared x equals 3 plus 3 cosine x. And now we'll get everything on one side, just adding and subtracting things. So we'll end up with 2 cosine squared x plus 3 cosine x plus 1 equals 0. All right, so again, we're going to factor it. So you'll have 2 cosine x here, and you'll have cosine x here. And 1 goes here, and 1 goes there, because you're looking for 2 numbers that multiply together give you 1, and the only possibilities would be 1 and 1. And so you want your middle term to be positive 3, so you'll be adding on both of these so that you'll have 2 cosine x and 1 cosine x for your middle term will add up to 3 cosine x. So again, you've got a product that equals 0. That means each factor has to be 0. So 2 cosine x plus 1 is 0. Cosine x plus 1 is 0. This means that 2 cosine x equals negative 1, and therefore cosine x would be negative 1/2, and that happens at 120 degrees and 240 degrees. So that goes with that one. And then over here, we've got cosine x plus 1 equals 0, so cosine x equals negative 1, and that happens when x is 180 degrees. Okay, this last one, you've got 2 tangent squared theta equals secant theta minus 1, and that is another one like this, where you can substitute secant squared theta minus 1 for your tangent squared theta. So I'm going to use the exact same substitution I used in the first example for tangent squared. So that's 2 times secant squared theta minus 1 equals secant theta minus 1. And if I distribute the 2, I'll have 2 secant squared theta minus 2 equals secant theta minus 1. Now I have a quadratic equation. I'm going to get everything on one side. So 2 secant squared theta minus secant theta minus 1 equals 0. I'm going to factor it. So 2 secant theta, and 1. I want a negative 1 for the middle term, so I will have to make this negative and this positive. So that means that 2 secant theta has to be negative 1, or secant theta is 1. If 2 secant theta is negative 1, that means that secant theta is negative 1/2, and that is the reciprocal of cosine, and this is telling me that cosine theta would have to be negative 2, and that never happens. As I said, cosine stays between negative 1 and 1. And then over here, we've got secant theta equals 1, which means that cosine theta is the reciprocal of that, which is still 1, and that happens when theta is equal to 0 degrees.